Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Today we have another meeting for discussion of chemical kinetics. This meeting we would like to learn first reaction rate, second reaction order, third rate law, fourth we would like to learn rate constant, and then half-life. Then in the last of this meeting we would like to discuss on temperature dependence on reaction. What is actually chemical kinetics? Chemical kinetics is the study of time dependence of the change in the concentration of reactants and products. As can you see in the reaction between H2, gas H2 plus I2, hydrogen and plus react with iode. And you know that that one is reactant producing Hi molecule. So chemical reaction involve forming and breaking of chemical bonds. Reactant molecules, in this case is H2 and I2, approach one another and collide, as well as interact with appropriate energy and orientation. Bonds are stretched, broken, and new bonds are formed. That's why then resulting in product of molecules then move away from one another, and that one is actually the products. Have a look the rate of reaction. Let's say we have 1 mole of I, and when first time initially without B molecules, then because of the time goes, initially we don't have B, only red. Red is the molecule of A, and then change. You know, when the time goes, we have the blue that representing B molecules. So in 1 second, I mean in the initial time, 0 second, only 1 mole of A. But when 20 seconds the reaction already go, we have only 0.54 mole of A and 0.46 mole of B. Then we leave it again until 40 seconds. You can see in the container that the molecule of B have more concentration than molecule of A. So the blue color is higher than red color molecule. Rate of reaction can be shown by R, and many of us also represent it by V. So can be R, can be V. If we have the stoichiometric equation, reaction between A and B, that one is reactant. A and B react, resulting in X and Y molecules with the coefficient of the reaction A, M, B, N, and XP and Y key. So how we write the rate of the reaction? The rate of the reaction can be shown as R equal to minus M, okay, dA per dt. I show you in better using the whiteboard. I can just writing it again, so easier. So here we have reaction. For example, A. This is M with this one is N. B. Then for choosing here X and Y. Here the rate of the reaction is given by, because you know the reaction itself is decreasing the concentration of reactants and increasing the concentration of products. So here the rate itself is represented by minus, meaning that this decrease the concentration of A per unit of time dt, and this must be time per m. That one also you know equal to minus n and dB per dt. Okay, and also that one is equal to plus. Why plus? Because that one is product dx per dt, and this must be per p equal to plus dy per dt. So this is the rate of reaction equation. The question now is, what is the unit of K? Unit of K. So again, in the integration, in the rate law, integrated rate law, we have R is equal to that one dA per dt, and this one is equal to K A, that one B, and this order reaction, let's say I can write it here M and N, but N M here, that one is not. That one is R not. R not again, not the reaction coefficient. From here, then we have a question. What is actually K? K, that one is the constant, reaction constant. And A here, this is molarity of A. So that one is molarity of B, and K is rate constant. What is the unit? This depends on the order of the reaction. Okay, we can go to the presentation. Have a look over there. You can see that, you know, the order, the constant itself depends the order of the reaction, and it is the same as by, you know, K is equal to, you know, R of the rate divided by the molarity powered by the order reaction. So the M and N are called order reaction, and again that one is not, are not reaction coefficient. Okay, so the unit itself as given on the presentation is equal to concentration powered by 1 minus M minus N divided by time. So unit of rate constant is depend on the order of the reaction. The factors that affect the reaction rates. First is concentration of reaction. It is very clear. As the concentration of reactant increase, so does that reaction molecules will collide more. So the collision between the molecule is more occur than the concentration is low. So when the frequency of collision is more often, then now the effective collision should be more than lower concentration. Again, factors that affect the reaction rate is first concentration of reaction. Why? Because more concentration, then more effective collision, then the rate of, the rate of the reaction will be higher. The second factor that affect the reaction rate is temperature. Why? Because at higher temperatures, reactant molecules have more kinetic energy, move faster, and collide more often with greater energy. And this, of course, then reaction rate will be higher. Now, the third factor that affect reaction rate is catalyst. Because the speed of reaction, they will accelerate the reaction by changing the mechanism of the reaction. Now we go for rate law. How does the rate law depend on the concentration? This can be found out by experiment. You see already, I show you that R, the rate law equation, is equal to rate constant times the concentration of reactant times each of the concentration of reactant powered by the order reaction. And rate constant K depend on the reaction order, and the rate constant equal to K when each of concentration equal to unity. Rate laws can be complicated. Sometimes it is very simple, just similar by the reaction, can be seen from the reaction.